Okay, so let's take a moment and work through some of the more implementation focused side of ADT. So in your queue and stack exercises, you were asked to come up with the signatures and possible example tests or function calls, and even pseudocode implementations for queues and stacks using both an array and a linked list, and no library functions other than print, range, and length. You are also asked to do this for bags and dictionaries, but this sequence of videos is going to focus on stacks and queues. We're also going to differentiate resizable from fixed implementations. Okay, so let's start with queue signatures. And so a signature is going to give us the name, parameters, and ideally the return information. If we were going to either use a queue library or sit down and implement it, we would have to have this information first and foremost. So adding an item to the end of the queue. One more thing. I'm assuming that we are working in object-oriented or OO land. Okay? So I'm assuming that we're going to call these functions by saying something like queue.enqueue, so that we have an object that we're calling these signatures on, and then this is our function. Okay, and we haven't yet defined what, if anything, is going in between there. So let's move on to that. So queues can add an item to the end of the queue, and so the signature for that is going to be something I like to be shorthanded, so I say NQ. And if we're going to add something to a data structure, we always must have a parameter, because how else will we know what to add? Your data structure doesn't know what new node you want to add or what new thing you want to add. You must give it a parameter. And I'll be honest, this one's probably void in this scenario, in this context. If we're getting an item from the front of the queue and removing it, so if we're dequeuing, we don't have any parameters, but we're going to return that item. Then if we're just going to peek at the item at the front of the queue, we also don't need any parameters, because when we want to retrieve information from our data structure, queues and stacks have very well-defined ways that we interact with them, so we don't need parameters to tell us. If I wanted to get information from a just straight array, I would have to have a parameter, because I need to know what index element. But with stacks and queues, these operations of dequeue and peek are very well defined. This one will also return an item just like dequeue. If the queue is empty, we are going to return a Boolean. I don't need a parameter because the queue data structure holds everything it needs to know to answer that question. I could also clear the queue. This also doesn't need any parameters. I would make this void. However, you could also return a list. Okay, so those are the signatures that we're trying to work with here. And you'll see these again elsewhere. Now that we have the signatures with the names and parameters and return information, let's see if we can figure out some example function calls to really make sure that we understand what these are doing. So we've got queue is empty. So if the queue is empty, it's going to return true. Let's try enqueuing something. So I'm going to just abbreviate my queue data structure as queue. I'm going to abbreviate NQ and DQ similarly. So let's say we're going to NQA. I'm not worrying about quotations or string literals or numeric literals, whatever this is. We're just going to go with it. So the queue before the call was empty, and the result will be A added to the queue. And let's add B. So with queues, we are adding to the end and we're pulling from the front. So I'm going to assume that we are adding this way. And if I'm going to dequeue, I don't have any parameters. I'm starting from our queue of A, B, and so I'm going to return, oops, the result is going to be B, and I'm going to return A. Because the first item that gets added is the first thing returned from DQ. And if I peek on A, whoopsies, this is not a stack, this is a queue. Oh, that didn't really work. There we go. Okay, so we've only got B left. My result is going to be B. And let's see, we've got, let's try is empty again. And we actually have something in our queue this time. So it's no longer empty, it's false. And then finally, let's clear. And let's say we had a little bit more in our queue, just for the sake of argument. The result would still be empty.